All right, so tomorrow on the formula sheet, I'll give you the triangle formula will be on there, 1/2 BH. Circle, pi r squared, and parallelogram BH. Okay, so those are on there tomorrow for you. All right, what about the ones you're going to have to know? Trapezoid. All right, you're responsible for the trapezoid. Rhombus. And just let me stop right here with the rhombus. Remember, the rhombus is 1/2 D1, D2. I can't stress this enough. The diagonals are not congruent. Okay, they will never be congruent. If they were, we'd call it a rectangle, not a rhombus. All right, so diagonals not congruent. You're going to have to find the length of each. So if I give you one of them is 10, that does not, it's not, the other one's not 10. There's got to be another way to find it. All right, and I want to go over rhombus properties here in a second after I'm done with the formulas. All right, what other formulas? Population density. There'll be a question on tomorrow's test related to population density. I think that's equal to what? Population over the land area. Sector of a circle. All right, how to find sector of a circle. And then a regular hexagon, regular octagon. All right, so I'm just going to put a regular polygon. Number of triangles times 1/2 base times height. All right, and all of these, I'm not going to write them out because all of them are listed in your packet on page 23. Okay, they're all listed there, even the ones on your formula sheet. So if you look on page 23, right at the top, there are all your formulas. Okay. There will be a composite figure. Just remember what a composite figure is. It's a figure that you don't have a formula for, but you can cut it up into figures you do know and have formulas for. Okay. I forget. I don't think I have any I'm going to do here today. I just want to make sure you're aware of I'm sure most of you know what I'm talking about, but I just want to make sure we're good. Where was yesterday's? Like this bad boy right here, 18. That's a composite figure. So 2 rectangles and a quarter circle, and I add them all up. Right, so you'll have a composite figure where you have to break it up tomorrow. Shaded region problem. Sorry, shaded region. Remember, that's the area of the whole thing minus the area of the unshaded. And then what we did on Friday, and I did again yesterday in class, area and perimeter of similar figures. All right, reminder, if you know the side ratio, that's equal to what other ratio? If I know the ratio of 2 sides of 2 similar figures, that's the same ratio the what are in? Perimeters, yep. But what am I going to have to do to that ratio to find what the ratio of the areas are in? Because what I'm writing right now is incorrect. I got to square which one? Sides. Square the side ratio. Yep, and you get the area ratio. Okay, please don't forget that. Just don't set up the sides equal to the area. You got to square the sides before you cross multiply. All right, couple other things I want to go over. I believe tomorrow I also put find the area of a graph figure. All right, what do I mean? Because I don't think I put any on the review, but I want to make sure you're good here. Let me just open up. Let's see. We probably did that day 1 on the homework, I think. Just to I'll let you remember the homework problem we had, what I'm talking about. Day 2. Yeah. Remember that one? Find the area of this triangle. 1/2 base times height is not going to help you here. Remember we had to box it in and go. Okay, find the area of the box minus the area of the 3 triangles will get you the area of there. Okay, so that's what I mean by area of a graph figure. I couldn't find any extras to put on your review or in the textbook, so just giving you a warning. All right, some other stuff. that has nothing to do with this unit, but you're going to need it to solve some of the problems. Your 30, 60, 90, and 45, 45, 90 rules. All right, remember those? Okay, because a triangle could end up being one of those. And also, if it's not one of those, but it's still a right triangle, be prepared to use SOHCAHTOA if you need it. All right, be prepared to use SOHCAHTOA. So there you go. There's the summary of the test tomorrow. Anything you want to ask before we do some of the review questions, which a couple of you may have already done already, but it's fine. We're all good here? All right, here we go. Go to your packet. Going to start calling on numbers. Number 7 in your packet. And again, some of you may have done this already. All right, find the area of that shaded region. I just talked shaded region, whole minus unshaded, right? Whole minus unshaded. All right, talk to me. What's the whole thing? What is the whole thing here? What figure is the whole thing? Start us off right. 5, what's the whole thing?
36.
Just the figure. You're getting ahead of me.
What do you mean?
Like what's the shape?
Oh, square.
Square, length times width, they're both the same. And Abbott already went ahead and said 6 times 6. Yep, it's going to be 36. Minus, describe to me these unshaded parts. What are these unshaded parts here? 8, what are these unshaded parts, Sophia?
They're all quarter circles.
There's quarter circles and there's 4 of them. So if I put them together, I'm going to get a full circle, right? All right, so pi r squared. So now I'm at 36 minus pi. What's the radius of one of those quarter circles there? 2. Yep. Yep. One more time, maybe. 8. Sophia, back to you. Sorry.
The radius is 3.
3 squared. Yep. And then I keep going. 36 minus, that becomes 9 pi. Look at the directions, everyone. In terms of pi, express your answer in terms of pi. There was only one problem, but we talked. You cannot combine those. Because if you do 36 minus 9, this is not equal to 9. It's 9 times whatever pi it is. Okay, so that's not equal to 9. So you can't subtract them. That's your final answer right there. 36 minus 9 pi. Okay, so there's a shaded region problem. All good. All right, I'm going to go a little quick through these just so you guys can have enough time to practice. All right, 5. Let's go to 5. The length of NL is 6 centimeters NL. This is an old Regents question right here, FYI. Old Regents one. The area of that sector is 2 pi, so the area is 2 pi. All right, so it's a sector problem. This is a formula I'm not giving you. You're responsible for tomorrow. Sector equals measure of the arc over 360 times area, pi r squared. I know it asks to find angle n, and we'll get to that. Trust me, we'll get to that. All right, what is the area of the sector? That's given to you. 9, what's the area of the sector?
2 pi.
Okay, so everyone, in for sector, 2 pi. 2 pi. Equals measure of the arc. I don't know that. That's going to be my x, but won't be my final answer. We'll talk about that y when we find it. Over 360 times pi. How about the radius of this circle based on what was given? Sophia, 8?
It's 3.
3, half of the diameter. Good. So 3 squared. Everyone see what's on the left and the right? That's going to cancel out eventually. Your pi's, they're going to be gone eventually, so let's get rid of them now. Hey! I don't know if this happens tomorrow or not, but if there's just a pi on one side and no pi on the left, you can't cross them out. Okay, it's only crossed out if both the left and the right side of the equation have them. If only one has it, you got to get rid of it by dividing it out. All right, so what do I have left here? 2 equals x over 360 times 9. All right, what would be your next move tomorrow then? Trying to get x by itself. What would be your next move? 4. What do you want to get rid of?
Multiply by 360.
Sure, multiply both sides by 360. I get 720 on this side, 9x on this side. And then divide by 9. All right, now we'll talk here. Now we got to go back to the circle unit from unit 10, last unit. That's 80. What did we just solve for? The measure of the arc. That's 80 degrees, and I'm looking for angle N. Anybody remember? Hey, angle N was called what back in the day? Oh boy, gonna have to dig deep here. Last unit, what was angle N called? 11 in the circle? Inscribed. There we go. Now dig even deeper. Somebody else. How do you find an inscribed angle? What was the rule? 3. Spence, what was my rule for inscribed angle?
It's half the arc is drawn.
There you go. So I'm going to take half of 80. And I tried to suck you in. Look, 80 was a choice. Pick me, pick me. Nope. 40, because you're looking for an inscribed angle. That's a diesel one right there. Beefy. Add in your own synonym. Jacked. Anybody else want to add in? Swole. Nice. I like it. Nice. I like it. One more. Any more? Before I
Say buff.
buff. I didn't say buff. Buff. Yep. All right. Yoked. No. Is that the ones on the street or no? That's a bad one. Sorry. All right. I'm embarrassed now. I should have just acted my age. Sorry. All right. Last one. Number 1. All right, regular hexagon. I don't have a hexagon formula for you, but we can find a triangle and multiply it by the 6 the hexagon has. We're told that a side is 18. Nice, so I already have a base. 1/2, 18. All right, you guys, I need your help with the height. So here it is. I need your help with this bad boy. What did I just do to the 18, though? I just drew that height in. What happened to the 18? 10. What happened to the 18 here? Nice. I like the vocab, too. You didn't say just cut it in half. Bisected. 9. I got to find an angle, though. I got to find an angle. I don't know if this is 30, 60, 45, 45. Heck, it might not be anything, and I got to use SOHCAHTOA. So what I would like first, and I always start out this, what was the angle I formed by those drawing in those 2 radii? Help me find that angle right there. What was the angle formed by these 2 radii? And remember how to find it? Maybe help, Spence? Remember how to find it?
You divide 360 by the side.
There you go, boss. 360 divided by 6 sides. That's a 60-degree angle. And the height bisected it. So, yep, this is a 30, 60, 90. 30, 60, and the 90 is already there. Where's the 9 across from? 9's across from 8, Sophia. Which degree measures the 9 across from?
The 30.
The 30, that makes it the shorter leg. Height is across from the 60. So what's my rule? What do I do with the shorter leg to get to the longer leg? 4. Shorter to longer. Come on, dig deep.
Times radical 3.
Yeah, there you go. So 9 radical 3. And what's the directions? Round. Oh, you son of a gun. Got off easy. Round to the nearest 10th. So plug it all into your calculator. If it says simplest radical form, well, if it does say simplest radical form tomorrow, that radical 3 gets put in your answer, and in the calculator, 1/2 times 18 times 9 times 6. All right. Anything else? Questions? Okay, we have plenty to do here. We got the packet work. All right, which I know some of you almost got done yesterday. So the packet's got 11 questions. And at the end of question 11, you're going to see review from the textbook. Please get a textbook and try those. All the answers are in the back of your packet for you. All right, all of them are in the back of your packet. All right, so plenty to do. If you get stuck, you know where to. Let's do this. Come on. We only got 3 quizzes and tests left for the year. 2 after tomorrow.